Now, the main thing you need to know, since I've already performed the factorization for you, I've already performed step 1. This is step 1 here. You have to factor things all the way, and that's already been done for you. And here's what the setup is. The setup is that it's of the form a over x minus 1 plus b over x minus 1 squared. We need another term for the square here, plus c over x plus 2. In general, if you have more powers, you just need to keep on putting in those powers. You need one for each of the powers. Why does it have to be squared? Okay, so good question. So why in the world am I doing this? Let me just give you one hint as to why I'm doing this. Okay? It's very, very much like the decimal expansion of a number, or say the base 2 expansion of a number. So for example, the number 7/16 is 0 over 2 plus 1 over 2 squared plus 1 over 2 cubed plus, is that right? So it's 4/16 plus 2 plus 1 over 2 to the 4th. It's this sort of thing. And I'm getting this power and this power. If I have higher powers, I'm going to have more and more. So this is what happens when I have a 2 to the 4th. I'll have to represent things like this. Now that's what's coming out of this piece with the repetitions here of the powers. So this is just an analogy with what we're doing. Yeah, another question over here. Yes, so this is an example, but it's meant to represent the general case, and I will also give you a general picture. For sure, once you have the second power here, you'll need both the first and the second power mentioned over here. And since there's only a first power over here, I only have to mention a first power over there. If this were a 3 here, there would be one more term, which would be the one for x minus 1 cubed in the denominator. That's what you just said. Okay, now, what's different about this setup is that the cover-up method, although it works, it doesn't work so well. It doesn't work quite as well. Cover-up works for the coefficients b and c, not a. We will have a quick method for the numbers b and c to figure out what they are, but it will be a little slower to get to a, which we will do last. Let me show you how it works. First of all, I'm going to do the ordinary cover-up with c. So for c, I just want to do the same old thing that I did before. I cover up this, and that's going to get rid of all of the junk except for the c term. So I have to plug in x equals -2, and I get minus 2 squared plus 2 in the numerator, and I get minus 2 minus 1, the quantity squared, in the denominator. Remember, I'm covering this up. So that's all there is on the left-hand side. And on the right-hand side, all there is c. Everything else got killed off because it was x minus 2 times that. That's 0 times all that other stuff. And the x minus 2 over here canceled. Now, this is the shortcut that I just described, and this is much faster than doing all that arithmetic and algebra. So altogether, this is 6 over 9, right? So it's c is equal to 6 over 9, which is 2/3. Now, the other one, which is easy to do, I'm going to do by the slow method first, but you can omit a term. The idea is to cover up the other bad factor. Cover up, so I'll do it both the fast way and the slow way, but I'll do it the fast way first, and then I'll show you the slow way. The fast way is to cover this up, and then I have to cover up everything else that gets eliminated, and that includes everything but b. So I get b on this side, and I get 1 on that side, so that's 1 squared plus 2 divided by 1 plus 2. So in other words, b is equal to 1.